Hey everyone, in this video, I'll be giving you a brief overview of using PyEmbeo to create graph embeddings for your Neo4j graph database. So Neo4j is a great graph database. It is fast, it's reliable, it's scalable, it has capabilities to store large amounts of data, and not to mention, it has a great community. While graph embeddings, on the other hand, are like a doorway to perform machine learning on graphs. Now, think of these as a long list of numbers that represent your graph structure, which can then be fed to any machine learning algorithm. Now, if you combine Neo4j and graph embeddings, you actually get a powerful way to tackle a lot of applications and a lot of use cases using both graphs and machine learning. Now, for this demo, I'll be using a simple graph as an example. So let me just head over and show you how my graph structure looks. So this is the Marvel graph network that basically shows which hero in the graph universe partnered with whom. So we have Captain Marvel over here partnering up with Iron Man. So we got the hero node that represents a hero in the Marvel universe and the partnership relationship that shows a collaboration between the two heroes. All right, now if I want to embed this graph, using PyEmbeo, you have a very simple command line interface. All you need to do is run a simple script. So my script over here is, let's say I want to train my graph embeddings. Now I give a unique project name for my graph embeddings. So basically this will help the script to create a directory with that project name that will store all your embeddings and your graph data. Also make sure that your graph data is up and running and you have the APOC plugin installed and configured for your graph database. You also need to provide the link to your graph database, but since I'm using the default configuration over here, it assumes that it's the local host available at port 7687. That's the standard de facto Neo4j database URL, right? Once I hit return, I am prompted for my graph credentials. So let me just key in those. And now you can see a bunch of logs that will tell you that your data or your embeddings are being trained, right? Now this takes quite a while. PyEmbeo uses PyTorch Big Graph to generate your embeddings. Now, one advantage of using Torch Big Graph is that it can handle very large graphs, like which scale up to millions of nodes. And moreover, it doesn't really require any fancy computing resource like a GPU. So this is all happening on the CPU, right? Now this will take about, let's say 15 to 20 minutes to generate your embeddings. So let me just head over and show you how your embeddings or where you can find your embeddings, right? So remember we provided a unique project name. So I have already trained the embeddings and so you can head over to your project directory where you have a subfolder called the model folder and you get your embeddings as an H5 file within it, right? There are a lot of parameters that you can actually configure, so you can actually alter your training process and more information is available in the documentation. But of course, if you want to keep it simple, you can just go ahead with the default configuration right now. One thing is that what can you do with your embeddings, right? And one simple task is a similarity search task that's offered in PyEmbeo. So if you give a particular node, you get similar nodes for it. So this is helpful usually in cases where you want to discover new relationships within your nodes in the graph, right? And this is extremely useful for things like, I don't know, knowledge graph completion or maybe drug discovery or even for finding co-occurrences in natural language processing. So if you want to do a similarity search, all you have to do is run the Python script. Again, give your project name. So I'm giving the Marvel project name over here that houses my pre-trained embeddings that I generated and the URL to my graph database. I'll again be asked for my graph credentials. So let me just key those in. And once I'm done, I get my top 5 similar nodes for my particular source node that I had given. So I have wanted to find similar nodes for Captain America, and I got the top 5 results as these. It's Vision, Jarvis, and hey, Iron Man is at number 4. Oh, great, right? All right then. That's all from my side. Hope you like the video. Of course, there are a lot of enhancements that can be added to PyEmbeo, and any suggestions are welcome. But I'll be signing off for right now. Thanks a lot.